now that we've got all our vocab for section 1.5, words like supplementary, complementary, vertical, adjacent, linear pair, perpendicular, we're going to use those words to actually apply them and solve some problems. So in this first example, we are finding x and y. Based on this picture, it looks like these two lines might be perpendicular, but we cannot assume that. You can only assume lines are perpendicular if that's told to you, or if there's a box in the corner of the angle showing you that it is 90 degrees. What we can assume, though, based on diagrams, is that anything that looks like a straight line is a straight line. So the angle created by either side of that line is 180 degrees. Same thing, the angle created by either side of this line is 180 degrees. So those two lines tell me I've got some linear pairs going on. Over on the left, 2y plus 50 and 5y minus 17 should add up to be 180 degrees. On the other side, 7x minus 248 and x plus 44 should add up to be 180 degrees. We could do the same thing top and bottom, but right now I don't want to do that because that would be mixing up some variables. If I look at just the tops, I've got y's and x's going on. Same thing on the bottom. You can do it that way. We just have a system of equations, which is something I don't really want to deal with. So instead, we're going to look at the left side and the right side. On the left side, I've got two angles. One of them is given by 2y plus 50. Another one is given by 5y minus 17. And those two, when added together, should be 180. Let's go ahead and solve this equation. 2y plus 5y is 7y. 50 minus 17 is 33. 180 minus 33 is 147. Divide each side by 7. Y is, I gotta throw that one in the calculator, 21. That's a Y. So there we've got Y to be 21. And then on the other side of my diagram, I've got 7x minus 248 plus x plus 44 should equal 180 degrees. 7x and x would be 8x. Negative 248 plus 44 should be negative 204. I'll add 240 each side. Eight x then would be 384. I'll take 384 divided by 8. X there should be 48. If we wanted to, we could plug those numbers in, double check, see that maybe our vertical angles would be congruent, but we're going to trust for now that those are right. All right, next we got angle E and angle F are supplementary. Supplementary, another word we know, that means they add up to be 180 degrees. The measure of angle E is 54 more than the measure of angle F. We want to find the measure of each angle. So I'm going to write out some equations telling me what I know. I know E and F are supplementary, so I know that the measure of angle E plus the measure of angle F will equal 180 degrees. I also know that angle E is 54 more then the measure of angle F. So whatever the measure of angle E ends up being will be the measure of angle F plus 54. I'm going to take my two equations, my green one and my orange one, and I'm essentially going to combine them. So I'm going to plug this in for the measure of angle E over there. So my equation is going to be the measure of angle F plus 54. Now I'm going back to my green, plus the measure of angle F will equal 180. We're going to treat this measure of angle F just like a variable. If you wanted to, you could even plug in a variable right now like x, y, f, whatever you want to use, and then put the measure of angle F back in at the end. But I'm lazy, so I'm just going to keep it there. We'll combine these to be 2 times the measure of angle F. If you wanted to use a variable, the parentheses is where you would put that, plus 54 will equal 180. I'll subtract 54 on each side. So 2 times the measure of angle F will be 126. And then I'll divide each side by 2. So the measure of angle F will equal 63 degrees. We can double check that if we want to. Actually, we don't even have to double check it. We have to find the measure of each angle. So there are a couple different ways we could find the measure of angle E. We could take this equation and substitute the measure of angle F in. So the measure of angle E is equal to the measure of angle F, which we just found to be 63 degrees, plus 54 degrees, should be 117. And then we could double check that. These two angles are supposed to be supplementary, and 63 plus 117 is 180. All right, based on this diagram, I know the measure of angle LNM is 8x plus 12. So angle LNM would go from L to N to M. So this angle is given by 8x plus 12. The measure of angle JNL, so that'd be an angle going from J to N to L. That guy is 12x minus 32. We want to find J and P, so we want to find this one. In order to do that, we're going to start by solving for our variable. Usually that's a good first step. Just like in our first example, anytime you see a line, you can assume that that's a straight line, that that's a 180-degree angle. So my green angle and my purple angle will add up to be 180 degrees. So 12x minus 32 plus 8x plus 12 should be 180. We'll solve that equation. Simplify first. 20x minus 20 will be 180. Add 20 to each side. 20x equals 200. Divide by 20. X would be 10. We didn't need x though, we wanted J and P. So we wanted this angle right here. There are a couple different ways you could do it. You could notice that the green angle and the red angle form a linear pair. So we could find the green angle and subtract it from 180. The way I'm going to do it though is I'm going to say, well, this red angle and the purple angle are directly across from each other. They're vertical angles, and vertical angles are always congruent. So the measure of angle JNP should equal 8x plus 12 80 plus 12 would be 92. I am jumping ahead of myself. Alright, and I think we are hitting 10 minutes right now, so we'll stop the video right there. I do have one more example problem, but we're going to do that one in class.